the revelations that have emerged from the James Webb Space Telescope, JWST, since its deployment in the summer of 2022 have caused quite a stir in the scientific community. It has triggered a seismic shift in our understanding of the universe, offering a deeper, sharper look into the cosmos than we have ever had before. As we eagerly awaited its results, many thought that we were about to confirm and refine the models of the universe we had developed over decades of astronomical research. However, as the telescope's high-resolution images flooded in, scientists and astronomers began to confront the reality that much of what we believed about the universe may no longer hold true. The insights from the JWST have forced us to rethink everything, from the formation of stars and galaxies to the age of the universe itself. The crisis that has unfolded since these findings has left scientists grappling with profound questions about our place in the cosmos, while simultaneously revealing just how little we truly know about the universe. In the initial excitement that followed the launch of the JWST, there was a shared sense of optimism. It was a triumph of human engineering, a technological marvel that represented our desire to explore the unknown. The JWST was designed to push the boundaries of space exploration and, most importantly, to peer into the distant past of the universe. Its mission was to uncover the earliest stages of cosmic evolution by observing galaxies formed in the infancy of the universe. For decades, astronomers had theorized about how stars and galaxies first emerged after the Big Bang, and they had developed models to explain these processes. With the power of the JWST, we were about to see those models tested in ways that had never been possible before. But as the telescope's images began to flood in, it quickly became apparent that these images didn't match the predictions made by the established cosmological models. The first major surprise came when astronomers observed galaxies that appeared to be much more advanced than previously thought, far earlier in the universe's history. These galaxies seemed to be well-formed and mature, exhibiting complex structures and features that contradicted the conventional view that galaxies should have taken billions of years to evolve into such states. What the JWST revealed was a picture of cosmic development that was far more rapid and complex than anticipated. For many scientists, this posed an uncomfortable challenge. If these galaxies were already so mature so early, it raised questions about the formation process and the underlying assumptions about the timeline of the universe's evolution. Could the universe be older than we thought? Could the Big Bang not have been the true origin of everything, as we had long believed? Could there be more to the story of the cosmos than a single cataclysmic event from 13.8 billion years ago? These questions began to multiply, and the answers seemed increasingly elusive. The JWST's findings didn't just challenge our knowledge of the universe, they seemed to suggest that our understanding was fundamentally flawed in ways that we had never considered. The crisis deepened as more data came in. The JWST's ability to observe the infrared spectrum, something its predecessors, such as the Hubble Space Telescope, could not do, allowed scientists to peer deeper into the universe's past, observing galaxies and stars that were formed during the earliest moments after the Big Bang. As the telescope peered further into space, it discovered galaxies that were not just older than expected, but also more evolved. These findings raised more difficult questions about how matter had evolved in the universe. How could these early galaxies have become so advanced so quickly? The notion that galaxies formed gradually over billions of years was now being called into question, with the possibility that the process might have been far more rapid and efficient than we ever imagined. One of the most profound implications of the JWST's discoveries came in the form of a renewed interest in alternative cosmological models, particularly those proposed by physicist Roger Penrose. Penrose, a Nobel laureate known for his work in the field of general relativity, had long argued that the Big Bang was not the true origin of the universe, but rather one moment in an ongoing cycle of expansion and contraction. In his model of the cyclical universe, the universe goes through periods of contraction, where it collapses inward, followed by periods of expansion, where it bursts forth into a new phase of existence. According to this theory, the universe is not a one-time event, but rather part of a never-ending cycle of birth, death, and rebirth. Penrose's theory, which he first published in 2015, had been met with skepticism from many in the scientific community. The prevailing belief, based on the Big Bang theory, held that the universe began from a singularity, a point of infinite density, around 13.8 billion years ago. But the findings of the JWST seem to have given Penrose's cyclical model a new sense of relevance. The images of galaxies that appear to be more advanced than expected could potentially be evidence that we are seeing the remnants of a previous cycle. In Penrose's view, each new iteration of the universe carries with it the structures and fundamental elements of the previous one. This means that the galaxies we observe today may not be the first galaxies to have ever existed, but rather the latest in a long line of galactic formations that have emerged over countless cycles of expansion and contraction. The cyclical universe theory could explain why galaxies in the distant past appear so advanced. If the universe brings with it the blueprints and structures from the previous cycle, then the process of star and galaxy formation could occur much more quickly than previously thought. This theory also has implications for our understanding of the very nature of the universe itself. Instead of seeing the universe as a one-time event that began with the Big Bang, we might need to rethink our entire cosmological framework to accommodate a universe that is constantly evolving through cycles of life and death. The JWST's revelations have not only challenged our models of galactic evolution, but they have also raised profound questions about the very nature of the universe's age and its ultimate fate. If galaxies are older than we thought, then the universe itself may also be older than previously estimated. The idea that the universe might have existed for far longer than 13.8 billion years forces scientists to reconsider the very methods we use to measure cosmic time. The conventional understanding of the universe's age is based on the observation of the cosmic microwave background, CMB, radiation, the afterglow of the Big Bang. This radiation provides a snapshot of the universe's early state and has been used to estimate the age of the cosmos. However, if the universe has undergone cycles of rebirth, the CMB may no longer provide an accurate measure of the universe's true age. But the mysteries don't end there. Another shocking revelation from the JWST was the discovery of a vast number of stars that have seemingly vanished without a trace. Using data from the JWST and comparing it with older catalogs from the Hubble Space Telescope, astronomers have found that over 771 trillion stars have simply disappeared from the universe. This is an extraordinary finding, as stars typically die in a process that involves a supernova explosion, where their mass is ejected into space, eventually contributing to the formation of new stars and planets. However, these stars did not explode. Their disappearance is sudden and without any clear physical explanation, which presents a major challenge to the fundamental laws of physics, particularly the law of conservation of mass. The law of conservation of mass states that mass cannot be created or destroyed, only transformed from one form to another. So how can so many stars simply vanish without a trace, leaving behind no remnants of their existence? The disappearance of these stars challenges our understanding of the processes that govern the life cycle of stars and raises the possibility that we are missing something fundamental about the way the universe operates. Could these stars have been destroyed in ways that we do not yet understand? Or is it possible that they have been hidden from our view by some as yet undiscovered phenomenon? Some theories have begun to emerge to explain this anomaly. One possibility is that advanced extraterrestrial civilizations might be using stars as massive power sources, perhaps by constructing enormous energy harvesting structures around them. This idea is inspired by the concept of a Dyson sphere, hypothetical structures built around stars to capture their energy. If such civilizations existed, they could potentially be hiding entire stars from our view, either by using advanced technology to obscure them or by redirecting their light in ways that make them invisible to our telescopes. While this idea is speculative and has not been widely embraced by mainstream scientists, the JWST's findings are prompting more open-mindedness towards such unconventional theories. The disappearance of stars, coupled with the discovery of previously unseen galaxies and the possibility of a cyclical universe, paints a picture of the universe that is far more complex and mysterious than we ever imagined. The JWST's findings have not only challenged our understanding of cosmic evolution, but they have also forced us to confront the limits of our knowledge and the possibility that much of what we thought we knew about the universe is wrong. These revelations have opened up new avenues for exploration and debate, as scientists struggle to make sense of the many mysteries the telescope has uncovered. And yet, there is something deeply humbling about these discoveries. Despite all our advancements in technology and our ability to peer deeper into the cosmos than ever before, we are still left with more questions than answers. As we look to the stars and the galaxies that stretch out beyond our understanding, we are reminded that the universe is far more complex than we can fully comprehend. The JWST has not only expanded our knowledge of the cosmos, but it has also revealed just how much we still have to learn. It is a sobering reminder that, despite our best efforts, the mysteries of the universe remain as elusive as ever. For now, we are left to marvel at the beauty and the mystery of the cosmos, and to acknowledge that we are only beginning to scratch the surface of its deepest secrets. With the continued revelations from the JWST, we can be sure that the story of the universe is far from over. As new images and data continue to pour in, scientists and astronomers will work tirelessly to make sense of the incredible discoveries that the telescope has brought to light. In the meantime, we can only wonder, what will the next discovery reveal about the true nature of the universe, and what new mysteries will it uncover? One thing is certain: the journey to understand the cosmos is far from complete, and the future promises to be just as exciting and unpredictable as the discoveries we've already made.